Good evening, everyone. Welcome to our office hour for today. And in this section, we'll be having Sam Wilson, who is a core developer in Ethereum, and he'll be walking us through execution spec tests. And Sam, can you take over?
Absolutely. Yeah. Cool. Okay. So, hi, I'm Sam. I work on the reference spec for Ethereum. We call it execution specs. It's one half of our team's kind of output. The other half is the execution spec tests. Together, we're called STEAL, which is specifications and testing for the Ethereum execution layer. If you like funny acronyms, we're EELS, and the other team is EAST. I guess I've been asked to give you a little bit of a walkthrough of what we do, kind of how our code is structured. I want to talk about some of the philosophy behind what we do, and then give a bit of a rundown on areas that could use some help. It's going to be a very informal talk today, so hopefully that's not too much of a problem. But with that, I guess let's talk about some background. So we started the execution specs probably around 2019 now, so it's getting up there in years. Surprising. So we started it to solve a problem where Ethereum was specified as a yellow paper, which is an academic paper written in very math-heavy terms, used a lot of Greek letters, and wasn't very understandable for developers. And then on top of that, there were a pile of EIPs or Ethereum improvement proposals that were stacked on top of it. And that made it very difficult to get kind of a snapshot of what the state of Ethereum is at any particular time. So our goal with this Python reference implementation is to kind of collapse all that down into a more understandable language for developers. We chose Python for that, and to be able to provide snapshots in time of what Ethereum looked like at any particular fork. I think, after 4 or 5 years, I think we've definitely accomplished our goal. We have a reference implementation that can sync Ethereum all the way up to Prog. It's very, very, very slow, and we'll talk a little bit about that later. But overall, we're starting to get contributors from EIP authors, from core developers, and so I think the project has grown really nicely. It's also gotten a lot bigger, and there's a lot of room for new contributors. So we'd love to have any of you guys who'd be willing to take a look at it to take a look at it. So yeah, I guess let's give a little bit of a walkthrough of the actual code itself. And if anybody has any questions, feel free to just post in the chat or yell out loud. I don't mind getting interrupted. Yeah, okay. So we're a fairly normal Python project. We try to follow Python standards as much as possible. So if you're familiar with the Python ecosystem, you should feel right at home in our project. Unfortunately, for the next probably month, we're kind of in like an intermediate stage where we're merging our repository with the tests. So a lot of this information will be sort of out of date, but you'll still be able to figure it out. It's not that big of a change. Anyway, so all of our important code lives in the source directory, and it's divided into these 4 categories. So for the purposes of this walkthrough, you can completely ignore Ethereum spec tests. When you get to writing a test for something you've implemented, definitely look at this, but it's outside the scope of what I know well, so I'm just not going to talk about it today. Actual specification itself lives in the Ethereum folder, and we have a series of associated tools that make development easier in the tools directory. And finally, we have a second implementation of certain important parts of the spec, namely the state database that we've rewritten to be faster. And that's how we're able to keep up with mainnet. Contributions to this repository in this program, I think you can mostly focus on spec tools and Ethereum. There is a second project that I'll talk about a little bit later called Doc, but like I said, I'll get back to that later. So the specification itself is organized into code that is common between all forks, and then each individual fork. So for example, you'll find like the ETH hash implementation here that's common to all of the proof of work forks lives in the common area. You'll also see stuff like Genesis, you'll see our tracing implementation, you'll see most of our exceptions, all of that kind of stuff lives in this common area here. So the actual meat, the interesting part of the specification, lives in the forks directory. Here you can see all of the Ethereum forks from Genesis all the way up until Osaka. And we do have a preview release of, or not a preview release, a preview branch of Amsterdam that we're working on over here. So if anybody wants to take a look at implementing new EIPs, that would be the place to contribute those. Let's start with Frontier because I think it's one of the easier forks to kind of get a handle on. Actually, let's start with a little bit of philosophy here. So comparing, let's say, Osaka, which is the most recent fork, to Frontier, which is the oldest fork, you'll notice that there is a lot of duplicated code between these forks. In fact, I'd probably say like 90% of the code is shared between them. Duplicated rather, not shared. This is kind of part of our philosophy of providing a snapshot of Ethereum. If you look at production clients, say Geth or Nethermind or any of them, you'll note that they have conditional statements within their code that depend on the currently active fork. We have explicitly taken a stance against doing that. So you'll find the entire implementation of Ethereum in Frontier, and then an entire implementation of Ethereum in Homestead, and so on for all the forks. And we do this to make it as readable and as simple to understand. So let's dive into some of the code here, and I can kind of give you a feel for what our code base looks like. So I guess stylistically, we follow a very C-like or procedural layout of code. We have plain classes or structs. I mean, in Python, there's no classes, but we treat them as if they're structs. So there's no methods attached to them. All of our methods are free methods, or free functions rather. And we do this mostly because this is how the consensus specs are organized. And it just helps keep our code a lot simpler. You don't have to worry about inheritance or object-oriented programming. What you see here is how the code acts, and there's very little side effects. We try to keep it as simple as possible. So here, what's a good thing to look at here? So yeah, I guess this is the blockchain. This is literally a list of the blocks in the chain, the current state, and the chain ID. So if you're familiar with blockchain, this should look very familiar. Apply fork is applied once at the beginning of each fork. This is used to implement things like, let's say, the DAO fork, where they have a state transition that needed to be applied. So that's what apply fork is for. And then you get right into the implementation stuff here. So state transition is how you add a new block. Sorry, where is it? I think it's apply fork, state transition. Okay, yeah, it is state transition then. So state transition is actually the entry point to each fork. So every time a new block comes in, you pass it to state transition. You set up block environment. You actually execute the transactions. You calculate all of the tries that have to end up in the block. You verify that the header matches the executed block, and then you add it to the blockchain. So it is literally as simple as that. That's kind of just an overview of our style. I don't want to get too much into the weeds about how all of this stuff works. You can look at it on your own. I'm available for questions if you have them. More architecturally, you'll find the state is important. It's the state database where contract and accounts are stored. The trie is the data structure that actually backs the state. The virtual machine directory contains everything relating to the EVM. So if you're working on an opcode or precompile or gas metering, it'll likely be in the virtual machine folder. Let's jump into control flow. It's pretty easy. You'll find that all of our instructions follow the same kind of pattern. We do stack manipulation, gas calculation, the actual change that gets applied, and then modifying the program counter. So if we look at a more complicated example here, like jump, you'll see we pop the destination off the stack, we charge the gas, we perform any checks that are required for jumping, basically that it's a valid jump destination, and then we increment the program, or we don't increment, we set the program counter. And the same pattern applies for all of our functions. Same thing for, say, Ketchak, same deal, stack, gas calculation, do the work, and then increment the program counter. Precompiles, same deal, a little bit more complicated than instructions, but still very simple functions. This one here is EC recover. There's no stack manipulation in precompile, so you go right into gas, you do the work, and then you set the output information here. So so if you want to find anything to do with the EVM inside the VM directory, I guess we can go look at Osaka, because I think there's a few more things in here. Yeah, so there's also, in more modern forks, there's also the concept of requests. These are contract triggered events that can happen, say like a withdrawal. They live in here. There's also a new introduction in the new forks. There's also system transactions. So system transactions are a new concept in newer forks. They're here too. So let's do github.io execution specs. So this is our rendered documentation here. Okay. So kind of showing the output of our process. Our goal is to be able to both show a snapshot of Ethereum and show the changes that happen in each fork. So this tool here, ethereum.github.io/execution-specs, shows you what changes between forks. So here we can see that in the Prague to Osaka fork, these constants were added. So we provide both views, we provide both the snapshot and diffs. Okay, so that's kind of like the whirlwind tour of our repository. I have missed a ton of stuff. I apologize for that in advance. Again, just reach out if you have any questions. Okay, since you're going to be contributing to our repository, or at least, sure, of course. So Steel as a whole, so both the specifications and our tests. The problem that we're trying to solve is that for a very long time, this document here was the specification for Ethereum. If you understand this kind of notation, then that's amazing. You should go work on a client right now. But if you're like the rest of us and you don't really understand this at first sight, and you're more used to programming languages, that's kind of what our specification is meant to do. We want to take this kind of academic notation and turn it into something more digestible for developers. Yeah, exactly. It's just trying to make things more accessible to more people. And then on the other side, the testing side, we provide, so the specifications, this code here is used to generate tests that other clients execute. So we provide kind of like a baseline implementation to compare against. Yeah, hopefully that answers your question. Yeah, I think Mercy, you have your hand up.
Yeah, so I have a question right here. Someone sent it actually. The question is, given that execution specs interact tightly with the consensus spec through the engine API, are there any open challenges in keeping both specs aligned, especially with upcoming changes like EIP 7251 GSPDS?
That is a great question. So for the most part, we pretend that the consensus layer doesn't exist. Part of our, I guess, definition is that we only receive blocks that are part of the canonical chain. So we don't have to deal with rollbacks or reorgs. Yeah, and that's basically how we deal with that, is we pretend it doesn't happen. As for which EIP were you talking about? 7251?
Yes.
Yeah, okay. So they add a request. So we would go into Osaka request. This one is due for Osaka, right? I think, or is it Amsterdam? Yeah, okay. So it's for a later fork. Yeah. So we would basically just add the request into our requests data here, and that's it. We just pretend we sent it to the consensus layer and ignore it otherwise.
Okay, thank you. And I have another one. It says with proposals like vocal trees and state expiry, how is execution specs preparing to model state transitions with that are much more complex than the current Merkle Patricia tree that Ethereum has?
That's another great question. So we're working on prototyping some of this work. We have a couple pull requests open here. Ooh, yeah, okay. So we have some people that are prototyping how these things might look. We're abstracting away from having our one state implementation, and we're creating an interface that would allow us to swap out different state implementations, but we'd handle it just like any other client. We'll do the work, we'll implement it, and that's pretty much it.
This is more like an interactive section, so you can unmute your mic. Okay, I guess I'll read it out. So it says, since the EVM cracks out to the final state roots, where in the spec code do we see the proof that the EL isn't cheating? Like who handles the messy Merkle tree stuff? Is that logic right here, or is it mostly abstracted away when they calculate the root?
It is right here. So we have a representation of the Merkle tree, or tree. I can never pronounce that word correctly. Yeah, so the logic is here in try.py, and then we use this to calculate the state root hash just like a real client would. Hopefully
Okay,
that answers
the
your question.
last question I have here is how does the execution spec people balance between being a formal executable specification versus remaining readable and approachable for client implementers?
I'd say we have like a loose priority. Correctness is obviously the most important thing, and then readability, and then yeah, that's pretty much it. Obviously, if the thing we have to implement is messy, the code is going to end up being messy, but we end up filling the tests. So it doesn't matter how messy it is, we have to implement it. That said, readability is one of our biggest priorities. We want to maintain like accessibility, readability. We want this to feel like it's something you could pick up in computer programming 101 introductory course and be able to read it. So we spend a lot of time trying to keep things simple.
Yeah, that makes sense. Then I have a question personally. So I wanted to know if With the current renovation from to steel, is there a plan to make the specs modular enough, like more like a plug-in experimental EIP without having you guys rewrite the entire portion of the repo when there is a new fork?
That's a good question. It's kind of a balance for readability, right? We don't want to create too many abstractions where they're not necessary because that makes things more difficult to understand. It increases like the cognitive load on developers. Great example of this is the state oracle stuff we've been working on recently. It's really hard to balance our lives as developers and being able to make changes easily versus our audiences being able to read the code and understand it. So your question is like whether we're going to go to a more plugin based architecture. I don't think so. I think we're going to keep it very tightly coupled, just because that makes it easier to understand. And your second part of your question about who's going to be writing the code, we've been encouraging EIP authors to implement their EIPs themselves, and I think that's been going fairly well. We get straight from the author's mouth or fingertips rather, their vision for what it should look like. And yeah, I think we've had at least 4 EIP authors contributing. So I think we're doing pretty well on that front, and that's the path we want to go down.
Okay, thank you. I think Rahuma has another question. What part do you advise beginners who want to contribute to your project to take? Where can we start from?
I mean, there's where I want you to start from and where you probably should start from. I would like to start knocking off the oldest issues. So go to the oldest open issues on our repository and pick one of those. They've been sitting around for a long time and we haven't had the bandwidth to work on them ourselves. That said, they're probably not the best place for a newcomer to start. We do have a kind of a difficulty tagging system. So you can find easy, medium, and hard. I don't know how many easies we have. Oh, we have a decent amount of easies. So this label here would probably be the best place to start for newcomers. They're not supposed to be difficult tasks, and they'll get you used to kind of our workflow. Right. That
Okay,
actually,
does that answer your question, Aruma? Sorry, go ahead.
that said, there is a whole other part that I should talk about here that's kind of tangentially related to execution specs, but also needs a lot of help, and that's doc. This is our tooling that we use to generate this website here. As you can see, this is a very ugly looking website. It's very basic and it needs some help. So if any of you have a lot of experience in front-end development, specifically like HTML or CSS, or you're a little bit less confident in your Ethereum coding, but still want to contribute, Doc is definitely the place to do it. There's tons of stuff that needs to be done, and I don't have time to work on it. So this would be a great place for people to come and contribute. I will warn you now, it is probably the messiest code I have ever written. So sorry in advance.
Okay, sorry, Sam. Do you mind dropping the link? Because I don't think this is included in the Ethereum repo. Thank you.
I don't get your hopes up. I guess I can talk a little bit about this. It's kind of, if you've ever worked with Sphinx in the Python community, or what else is there? JavaDoc, like any of those kind of things. This is a similar tool, except it's basically custom built for our specs stuff. The architecture of it is fairly simple. Each input file is transformed through a bunch of plugins to create a single output file. Oh, you can just work on whatever you want on this. There are not a lot of issues. You can find something you want to make better and make it better. So yeah. So each input file is transformed through a series of plugins to generate an output file. Right now, the outputs are all Python or HTML, and it does a lot of tree-based abstract syntax tree manipulation. So yeah, again, if you feel more comfortable with this, please take a look at it. If you have any questions, let me know. There's not a lot of documentation on it.
Thank you very much, Sam. I don't know if anyone has any questions, and this is like the best time to get things sorted out. And I believe most of us are already working on execution spec itself. So if you have any questions, concerns, this is the best time to shoot your shot.
Oh, something I should mention is we generally don't assign issues to outside contributors. So if we don't assign an issue to you, that doesn't mean don't work on it. Just pay attention to other people's comments and try not to step on each other's toes. Yeah, I guess that's just one quirk of our process.
Thank you. So, okay, another question came in. It says, okay, are there areas where execution spec is more opinionated than the consensus spec, and how are the such divergence reconciled? I think this is similar to the one you answered.
I didn't quite catch the end of that.
It says, are there areas where the execution spec is more opinionated than this consensus spec? And how are the divergence reconciled?
Yeah, they aren't. They're completely separate projects and we don't talk to each other. So there's no reconciling of anything. There is a kind of a loose project that we've been working on to use some of the same libraries. So we have Ethereum types and Ethereum RLP, which are implementations of like basic integer types and RLP serialization and deserialization. We've been trying to kind of unify on those, but it's slow going and it's not really required.
Okay. So I have one more question about the generator and the filling test. How does that really happen? Like, how do they fill the test? How are the tests generated? I think that should
Sure.
be on the
Yeah.
spec test itself.
I mean, I can give you a little bit of a quick rundown here. And while I'm setting up for that, I can answer this next question here. So we won't assign the issues, but you can definitely make a comment saying that you're willing to work on it. And then just if you see a comment like that, don't step on somebody else's toes. But yeah, we don't generally assign issues. Yeah, cool. Okay. So I can't promise that this is gonna be work. I'm kind of in the middle of other stuff, but yeah, I can give a little bit of a rundown on filling the tests. So I definitely recommend using a virtual environment when you're setting up execution specs. We install a lot of libraries and stuff, and you don't want to mess up your system. Definitely do one of these. Okay. So filling tests. So um, let's see. Um, pull up, I don't know. Yeah, so there are broadly three kinds of tests. So the first type are our own tests. Some of those are in EVM tools, and a few of them are in JSON infra, test tools, test trace, like like these ones. They are just regular Python unit tests. They don't get filled, so you can ignore those for that. Then there are the JSON infra tests. These are the post-filled tests. So if you're kind of familiar with how the tests work, or if you're not familiar, I suppose, there is a body of Python tests that when executed will generate JSON files that are then, those JSON files are consumed by Geth, Reth, all the execution clients. So the JSON infrastructure, the JSON infra folder, we run those JSON files against ourselves just to kind of verify that they still work. You don't need to modify anything in the JSON infra folder. The where you're actually going to be writing and modifying tests will be in the East folder. This is an area that will change dramatically in the next couple of weeks. So I guess just try and pay attention to the way the repo changes. We'll have documentation and some guides. Just expect a lot of changes in this area. So, test, push. Okay, so I'm not super familiar with the tests. Let me just say that right off the bat. That said, they are fairly close to normal Python tests. You construct a transaction, you construct the post state that you want to see, and then you call a state test, or there's also blockchain tests. The East team will have a lot more information on this. Go talk to them. But I can at least show you how to fill the tests from our code. So running our test suite is pretty simple. We use talks. It's kind of like make, but for Python. We have our static tests, which are things like our linter, our type checker, and like source code formatter. Before making a pull request, you have to run this command or we will not look at your pull request. It will generate a bunch of stuff, fix it. It's not too hard to deal with. There's also a plugin for Visual Studio Code. I'm not familiar with it, but it exists. The actual test running, you can run like this, which is talks. There's also PyPy3. Those are documented in our contributing guidelines, which are available in contributing.md. Kind of gives you a rundown of stuff you should know. Read this. For filling a test, you run fill. This is a command that's provided by the East team. And let's say we want to fill that one test that we just looked at. So frontier, opcodes, push. Is it push? Is it not push? Test push. You can do things like specify what forks you want to run on. So we're going to run on fork Osaka. And then I think you need to specify clean. Let's see if this works. Anyways, this is the general idea of how to do it. Couldn't tell you why it's taking so long right now. this is probably just my computer screwing up. It should not be this difficult for anybody else. Yeah, so that's how to run tests. That's how to fill them. And for writing tests, talk to the East team. That's pretty much all I can say on that topic.
Okay, thank you very much. Judith, you have a question. Can you unmute your mic?
Thank you, Mercy. Thank you, Sam. This is my question. You said something just now that there's a command you have to use to run the tests. I just missed it. Did you mean that the talks-e static thing?
Yeah, okay. There are 3 bits of tests to run. Talks-e static is the preliminary set of tests. So you run that first. Then once that passes and you're ready to submit your pull request, you'll want to run either just plain talks, which will run everything, or talks-epy3, which runs a single iteration of the tests. There are various combinations of the tests that we run, but this is the most important. And if you want to run a specific test, like let's say you're writing your own and you want to make sure that it runs, you would use the fill command.
Okay, so is there any way we can get those commands? Are they written down anywhere? Like, are they in the...
Yep. Yeah, there should be in...
Okay. While you're answering that, where you can get those commands, the other question is that command running the tests, is it for every issue one gets, or when you strictly go to the test side, you just want to run the test when you want to hit the test repo? I don't know if I phrased that well, because there is now the execution layer, and then there's consensus, and then I think there's those who choose testing in between there. So is this for everyone? As long as you picked any issue on the execution layer, you have to run these tests this way?
Yes, exactly. Or for just the execution layer. The consensus layer has their own testing framework.
Or these commands are just for execution layer?
Yep.
Because I got some blockers. I tried to create my own file to run the tests. I'm not sure if that's allowed, because this was one of the questions I wanted to ask. I was getting issues running the tests, making sure the tests pass. So I don't need to create any other file. I just need to run these commands.
Yeah, so the talks command will give you the best chance of everything passing.
Oh, please, I really request to know where I can get those commands. Well, a set of like...
Yeah, they are written somewhere here. Well, I will find it and I will link it in the Discord because, yeah, I will. Sorry, I can't find it during the call. It's been lost in the shuffle, apparently.
Okay, that'll be very good for us. So as we're at a block, we need those commands to run the tests.
Yep, I'll make sure that's available.
You didn't answer this part where I said, is it okay to create another file to do the tests, or I just need to make changes within the files that I clone and just run these commands?
So I guess if you're adding a new category of tests, you're more than welcome to add like a Python file for it. If you're adding a file, like let's say a bash script to run the tests, we'd prefer not to add that.
Yeah, it was strictly a file to run the test.
Yeah, so that should be just talks to run the test.
Oh, thank you.
Thank you very much, Sam. I don't know, do we have any last questions you want to ask? Zara, you're mute. Are you trying to say something? Are we good to go? Do we have any other question we want to ask Sam? Just feel free to raise your hands and ask away.
I found it. So this is the updated documentation for running the tests and all of our tooling. I will also send it in the Discord.
Thank you very much, Sam.
Sam, is that the file you just dropped for the command, test command?
It should be in there. Yep. Yes, it is all in there. We just, like I said, we're in the process of moving a lot of things around. So this hasn't been merged yet, but the documentation, the test running information is in there. Okay.
Yeah. About the links, I will also share the links on Discord so that in case we miss it here in the chat. Is there any other questions before we wrap up? Yes, that will be all for now. Thank you very much, Sam, for this section. Thank you very much, everyone, for joining us, regardless of the time zone differences. And hoping to see you guys tomorrow for our office hours. And that will be all. Bye. Thank you very much, Sam.
Thanks, everyone.
Thank you, Sam. Thank you, everyone.